Good morning, guys. It has been a weird week yet again for all of us. I do sincerely hope at this point now everybody does have power, Wi-Fi, and that you're doing well. I don't know how much more we can take of all this insanity, but hopefully the this will be behind us before too long. Um, really don't know what the future holds as far as us seeing each other in school within any reasonable time frame. Um, I know that there's supposed to be a call from the governor today to the superintendents. Maybe that'll be addressed. I'm sure that's what's going to be addressed, but really, I don't know what's going to happen yet. I really miss you guys, and I'm just really anxious to kind of get us back onto a sense of some kind of normalcy. But anyway, several of you were able to get your test in early last week before the storms hit, and that was great. Those were graded and posted. And then many of you, did let me know you had encountered some difficulties with electrical issues and Wi-Fi connectivity. And then you went above and beyond and went through some acrobatics to make sure that that test was submitted to me. Several of you, messaged me and said, "Hey, I drove to town so I could submit this." I did not expect you guys to go that far for that. It was very much appreciated, and I'm just very grateful that I have so many students who are very conscientious about how they're performing in class. As you all are aware, this is an EKU class, so we have to push forward. We can't keep delaying things. This is not necessarily a Perry Central class so much as it is the EKU class, and EKU is not as forgiving as the public school systems. They do expect us to keep moving forward. Last week was not part of the plan. I have reached out to EKU to try to get us a little more leniency as far as maybe extending the semester for you guys, but that's going to just have to wait and see what they say. If you have not submitted your test to me, please get that to me by midnight tonight. After midnight tonight, I will have to deduct points for the test being late. I don't want to do that, but I try to be very understanding and generous, and I don't want that to be taken advantage of. Several of you still are way behind on Section 2 homework. That all will be due by Friday of this week. If you do not have all of Section 2's homework submitted by Friday of this week, that will also be reduced in point value. You've had ample time to work on it. I do realize that you were having issues last week, but even regardless of that, there's still been plenty of time to do the homework for Chapter 2 or for Unit 2. So I'm giving you fair warning to please go ahead and get those things taken care of. Test is due tonight. Unit 2 homework is due Friday, all of Unit 2. Anything beyond Friday for the homework will be receive deductions in the point value. Okay, I hate having to do stuff like that. But anyway, what we're looking at today is going to be relatively easy. There's not a lot of calculations involved. This is more about understanding and thought processes. It's not going to be mathematical yet, but we will develop more of the math here when we start looking at hypothesis tests and inferences. The notes you're going to notice too from this point forward are going to be slightly different. The notes that I'm going over today, I'm actually not going to be writing anything on the screen because there's nothing really to write. Everything that I want to express to you will be in red. And these notes will be posted, so there's not really anything for you to print out and fill out as we go along, but you can make your own little notations on here as we go if you would like. From today on, the notes will look very similar to this. Now I will be writing on these as we go, but I'm also going to release a completed version of the notes to try to make things a little bit easier for you guys. This is just so weird, the whole thing is. But anyway. As you can see looking at your screen, we are talking about the nature of hypothesis testing. And the hypothesis testing is when we want to test what we say is called the null hypothesis and the alternative hypothesis. The null hypothesis is what we presume to be true. And then the alternative hypothesis is what maybe we're researching to see if that may be true. You can see right here in the middle, the second paragraph there, one of the most commonly used methods for making such decisions or judgments is to perform a hypothesis test. A hypothesis is a statement that something is true. For example, the statement, the mean weight of all bags of pretzels packaged differs from the advertised weight of 454 grams, is a hypothesis. You can see here in the green box where we're talking about the different types of tests. The null hypothesis is the hypothesis that will be tested, and we use the symbol H naught, that's the sub-zero there, to represent the null hypothesis. The alternative hypothesis is a hypothesis to be considered as an alternative to the null hypothesis, and we use the symbol H sub A to represent the alternative hypothesis. And then the hypothesis test will be used to decide whether the null hypothesis should be rejected in favor of the alternative hypothesis. Now, that's not to say we accept the alternative hypothesis. We're just saying that we either accept or reject the null hypothesis based on the information that we end up obtaining as we go through some of the problems that we're going to see later on. Not in this section, but in future sections. So, when we talked about the packaging example, the null hypothesis could be that the mean weight of all bags of pretzels packaged equals the advertised weight of 454 grams. The alternative hypothesis might be that the mean weight of all bags of pretzels packaged it differs from the advertised weight of 454 grams. Now, when we say differs, we're actually going to get more specific as we go. But here we could say it's less than the advertised weight, it's greater than the advertised weight, or we can simply say it's not equal to the advertised weight. And all three of those scenarios have different implications with hypothesis testing. So the first steps in setting up a hypothesis test is to decide what is your null hypothesis and what's your alternative hypothesis. So there's going to be some guidelines that we want to consider before we try to start putting these into practice. So for the null hypothesis for a hypothesis test concerning a population mean, which is mu, always specifies a single value for that parameter. So we can express the null hypothesis as H sub naught or H sub 0 or H naught is mu is equal to mu naught, where mu naught is going to be some number. In the packaging example, that would have been 454 grams. The alternative hypothesis, we end up with the three scenarios that I mentioned before. We have the scenario where it's not equal to, and that's the first one you see here, and that's what we call a two-tailed test. The second scenario is where it is less than some value, and that's called a left-tailed test. And then the third scenario is where it's greater than, and that's what we call a right-tailed test. And then the left and right-tailed test can also be considered to be one-tailed tests as well. So let's go back and look at the scenario with the pretzel company. So they produce 454 gram bags of pretzels. Although the actual net weights deviate slightly from 454 grams, and they do vary from bag to bag, the company still insists, though, that the mean net weight of the bags is 454 grams. So they set up a quality assurance program, and they perform a hypothesis test to decide whether the packaging machine is working properly, which means to say that they're trying to decide whether the mean net weight of all bags packaged is 454 grams. Now, like I said before, we're not going to do mathematics in this particular set of notes. It's just interpretation and getting a feel for what these tests are. So for part A, it says determine the null hypothesis for the hypothesis test. Part B, determine the alternative hypothesis. And then part C, classify the hypothesis test as two-tailed, left-tailed, or right-tailed. So for part A, we're looking at the null hypothesis is that the packaging machine is working appropriately, which is to say that the mean net weight of all bags is equal to 454 grams. And you can see the notation there that H naught is mu is equal to 454 grams. That is our null hypothesis. For part B, the alternative would be that the packaging machine is not working properly, which is to say that the mean net weight bags is different from the advertised estimate of 454 grams. So in this case, our alternative hypothesis is represented by H sub A is going to be mu is not equal to 454 grams. And if you look back above this example, when we looked at the three possible scenarios, part C is answered by looking at one of those three scenarios. Because we use the not equal to symbol, this is a two-tailed test because the alternative hypothesis is the one hypothesis test that includes the not equal to symbol. Example 2 is something that we have seen before as well. We've talked about the height of women in their 20s a half century ago, and then we wanted to compare that to women in their 20s now. So here we're going to look at the average U.S. woman in her 20s was 62.6 inches tall. That was 50 years ago. Suppose that we want to perform a hypothesis test to decide whether today's women in their 20s are on average taller than such women were 50 years ago. Part A, determine the null hypothesis. So the null hypothesis is that the mean height of today's women is equal to the mean height of the women in their 20s 50 years ago. So we get H naught is mu is equal to 62.6. That's our null hypothesis, that the average heights are the same. Part B, the alternative hypothesis, it is looking at whether the women are actually taller than women of a half century ago. So here we're looking at the alternative hypothesis being that the mean height of today's women in their 20s is greater than the mean height of women in their 20s 50 years ago. So we get H sub A is mu is greater than 62.6. And then determining what type of test this is, we look at the symbol used in the alternative hypothesis, which is greater than. And because it is a greater than symbol, this is a right-tailed test. One more example. We're talking about calcium being the most abundant material in the human body. Recommended adequate intake of calcium for adults is 1,000 milligrams per day. So suppose that a hypothesis test was conducted to decide whether the average adult with an income below the poverty level gets less than the recommended adequate intake of 1,000 milligrams. Part A, determine the null hypothesis. So here we're looking at the null hypothesis is that the mean calcium intake of all adults with incomes below the poverty level is equal to the recommended adequate intake of 1,000 milligrams per day. So we get H naught is mu is equal to 1,000 milligrams. The alternative, here we're looking that they get less than the recommended adequate intake. So our alternative hypothesis is that mu is less than 1,000 milligrams. And then when we classify the test as two-tailed, left-tailed, or right-tailed, we see that we've used the less than symbol, which means that this is a left-tailed test. So why do we do this? A lot of times we have to conduct these because we want to make predictions, and we're going to see this later on in this unit, about the population as a whole. So we've talked about before how it's not practical to sample, say, the entire U.S. population, survey the entire U.S. population, but we can sample the U.S. population. And then based on that sample, we can make predictions and estimates about the entire population. So here you can see the basic logic of hypothesis testing is that if we take a random sample from the population, if the sample data is consistent with the null hypothesis, we do not reject the null hypothesis. If it's inconsistent, then we reject the null hypothesis in favor of the alternative hypothesis. Now, that's not to say that the alternative hypothesis is 100% correct. It's just saying that based on our information that we've gotten from, or that we've obtained from the sample data, indicates that the null hypothesis is probably incorrect, which leads to this next section where we talk about type 1 and type 2 errors. A type 1 error, and we're going to go into these in more detail in the next set of notes, but a type 1 error is when you reject the null hypothesis when it is in fact true. A type 2 error is when you don't reject the null hypothesis when the null hypothesis is in fact false. And we're going to see here on this flowchart, you might want to use these as you go. There's two different flowcharts here. Here's the first one. So you start, and if the null hypothesis is true, if you answer yes, do you reject it? Then if you say no, then you've made the correct decision. You've accepted the null hypothesis. If you rejected the null hypothesis and it is in fact true, then you made a type 1 error. Going down the flowchart, if the null hypothesis is not true and you do reject it, then you made the correct decision. If the null hypothesis is not true and you did not reject it, then you've made a type 2 error. And here is a second flowchart where we look at do you reject the null hypothesis? Yes. We're moving to the right here. Then is the null hypothesis true? If it is not true, then you made the correct decision by rejecting it. If it is true, then you made a type 1 error. We're going to see more of these, and they'll make more sense. Then if you go down the flowchart, did you reject the null hypothesis? No. Is the null hypothesis true? Yes, then you made the correct decision. If you rejected it and it's not true, then you made a type 2 error. And we're going to see that here in this example. So we're talking again about the pretzel packaging hypothesis test. And our null hypothesis, you can see, is that the mean weight is 454 grams, which indicates that the packaging machine is working properly. The alternative hypothesis is that the mean weight is not equal to 454 grams. So remember, not equal to can be either greater than or less than. And this would indicate that the packaging machine is not working properly. So if we were to obtain a type 1 error, remember, a type 1 error occurs when the true null hypothesis is rejected. So in this case, a type 1 error would occur if in fact our mean was 454 grams, but the results of the sampling lead to the conclusion that the mean is not 454 grams. And we're going to also see again later on in probably a couple of days here that we can still be, say for example with this 454 grams, if we're relatively close, we're going to have a margin of error. If it was 453 grams, if the average was 453 grams, would that lead us to conclude that the null hypothesis is incorrect and should be rejected? Most likely not, because it's within a gram. If it was less than, if it was say 20 grams, less than or greater than the expected average, so we're looking at 434 grams or 474 grams, then we would most likely reject the null hypothesis in favor of the alternative hypothesis. For part B, a type 2 error, that occurs when a false null hypothesis is not rejected. So the null hypothesis is false in this case, but we don't reject it. So in this case, a type 2 error would occur if mu is equal to 454 grams, but the sampling failed to lead to that conclusion. And then a correct decision can happen in one of two ways. The true null hypothesis is not rejected, or a false null hypothesis is rejected. And then we get down to part D, where we're looking at suppose the results of carrying out the hypothesis test lead to the rejection of the null hypothesis, where mu is 454 grams. That is, to the conclusion that mu does not equal 454 grams. So we want to classify the conclusion by error type. So the mean net weight, mu, is in fact 454 grams. Now keep in mind we have rejected the null hypothesis as stated just above part D here. So we reject the null hypothesis, but mu is in fact 454 grams. So if mu is 454 grams, the null hypothesis is true. And if we reject a true null hypothesis, we have created a type 1 error. For part E, if the mean net weight is in fact not 454 grams, we are rejecting the null hypothesis because it's not equal to 454 grams, which indicates that we have made a correct decision because we rejected the false null hypothesis. Probabilities of making an error with type 1 or type 2, you can see here in red. For a fixed sample size, the smaller we specify the significance level alpha, the larger will be the probability beta of not rejecting the false null hypothesis. So you always have to kind of look at what's the trade-off with accepting or rejecting or accepting a null hypothesis. And you also have to consider your significance level, which we're going to look at again later on as well. So when we look at the questions that you have on the homework here, for 1 through 5, yes, it has 3 parts. It's just like what we did on the first 3 examples. Though. You want to state the null hypothesis, you want to state an alternative hypothesis, and then classify the hypothesis test as two-tailed, left-tailed, or right-tailed. So remember, you look at the alternative hypothesis. If you use not equal to in part B, then part C is going to be a two-tailed test. If you use less than in part B, then you have a left-tailed test. And if you use greater than in part B, you have a right-tailed test. So that's 1 through 5. 6, you want to refer back to question 1 on the homework itself, not the example. And you want to classify what a type 1 error would look like, what a type 2 error would look like, and what a correct decision would look like. Looking back at the two error types. And then you also want to do classify conclusion by error type as a correct decision if in fact the mean lactation period of gray seals equals 23 days or differs from 23 days. So differs would mean not equal to. So there's your little hint for part E. And then that's it, except for 7, sorry. And then you're going to look at question 5 and do the same thing that you did for question number 6. So like I said, this is not a calculation heavy. This is more of an interpretation heavy set of notes. And then tomorrow when we do this again, we'll be picking up and we'll actually start doing some more calculations. And I think if you get a handle on what the alternative and null hypotheses mean and how to find them, then the whole unit is going to be relatively simple for you. I believe there's only 8 days in this unit. I've already got this week's notes all completely typed up, and I'm into next week's notes now. So that means we will probably have a test by the end of next week. It will be very similar to the last one you just took. I will generate the test. You can work together, and you will create your test based off the questions that I provide. Don't forget to get your test in to me today if you have not already done so. And remember, Unit 2 homework will be due by Friday. I really hope you guys are doing great. Please let me know if there's anything I can do to help you out, to make things easier for you. Love and miss you guys, and I'll be talking to you soon.